going to get things underway. But like I said, thank you so much for joining us today. We are excited to get started with you. And so if this is your first time, we're happy to have you. And if you are back a second or third time, welcome back. We hope you enjoy this program with us today. And I'm excited to get you to meet Sarvagya and Yash, our two engineers who will be doing today's presentation. Our topic for today is Streamline Your Observability and Security with Elastic Agent and Fleet. So we're going to get started on that shortly. But before we do, I would like for Sarvagya and Yash to give an introduction about themselves. If you don't mind sharing with the audience about your journey in this industry up until today, and maybe also what your favorite Elastic feature is. Go ahead, Yash.
Hello, everyone. Thank you for joining today's webinar on Elastic Agent and Fleet. My name is Yash, and I've been working in DevOps space for several years now. With a strong focus, on observability and search solutions. So my journey started with a backend development, but I gradually moved into engineering and cloud technologies, like where I found my passion in building scalable monitoring and logging solutions. So over the last few years, I have specialized in Elastic Stack, like in deploying and managing ELK-based observability and search platforms. And talking about my favorite feature in Elastic, so definitely it's machine learning, because especially it's for anomaly detection capabilities. Over to you, Sarvak.
Hello everyone, my name is Sarvagya Tiwari and I'm currently working as technical Elastic consultant at Hyperflex. So my journey began with a strong foundation in software engineering as well. I first discovered my passion for optimizing, system performance and ensuring reliability. Then over time, this interest evolved into a deep focus on observability, scalability, and security. And ultimately leading me to specialize in Elastic Stack. So through my work, I have had first-hand experience with how powerful Elastic can be. But one of the standout features of Elastic is the real-time search capabilities, allowing many organizations to quickly query large data sets and identifying issues in a blink of an eye. So yeah, I'm excited to share some of these experience with you today and dive deeper into how Elastic can empower teams into their observability journey. Yeah.
Awesome. Thank you so much for sharing that, guys. Now, at the end of the presentation, we will make time for a Q&A session. So if you have any questions throughout the presentation, feel free to just leave it in the chat and we'll take care of it then. All right, I'll give the time over now to you, Yash and Sarvagya. Please go ahead.
Okay, so Elastic Agent and Fleet is a game changer, like for the teams who are dealing with logs, metrics, traces, and security data. So we will walk you through how it works and why it matters and how easy it is to get started. So let me share my presentation. Okay, so today, here's our agenda for the today. So we will first cover the basics of Elastic Agent and Fleet. Then we will be showing you a real world demonstration of how you can deploy and manage your Elastic agents and integrate them with the fleet. And then we will look under the hood, like the architecture, that how Elastic Agent works alongside Fleet and Fleet Server, like both in Elastic Cloud and self-managed deployments. And then we will wrap up this presentation with your questions and answers. So before we dive in, let's acknowledge some of common pains of bringing data into Elastic. Installing many different beats or logstash pipelines, editing YAML by hand, etc. So let me detail some of the challenges. You are having multiple components like file beat, metric beat, hard beat. Each had its own configuration. So that's a lot of overhead, especially when your infrastructure scales. So editing lengthy ML files can be error prone. Your DevOps team spends a lot of precious time debugging syntax and identifying any credential issues. So managing the user account in beats on every host can quickly become unmanageable. So like this is for the audience, like, how many of you have spent the hours troubleshooting a single missing space in a YAML file? So let me see if anyone in the audience have spent their time in troubleshooting the YAML files. Okay, like I can see some hints. So yeah, definitely. That's why Elastic decided to unify their data collection under a single agent, which is Elastic Agent, to simplify everything from deployment to management. So before, like on every host, we were having file beats, metric beats, a heartbeat for uptime, and endpoint for security, and winlog beat for your Windows data. So previously, you need to install a separate beat for each use case. But in the case now with Elastic Agent, you have a single piece of software that handle all your logs, metrics, security, uptime, and more. So you drastically reduce your number of separate components to install and maintain. This single agent approach will help you standardize your environment and will reduce your configuration drifts. So let's say, for example, if you had 1,000 hosts and each needed 3 different beats, so total you will be needing 3,000 installations. But now with a single unified Elastic agent, that's just 1,000. So you can see how far this number got changed. So now let's quickly look at some key benefits of agent based ingestion over beats. So on this side, I have covered some key benefits of agent-based ingestion over beats. So in the case of Elastic Agent unifies your config into a user-friendly UI in Kibana, which you can use to push config changes from a central place, which will ensure consistency. And for the beats, you will still get data in, but there's a lot of overhead per beat. And there are many manual steps for each module or integration. So why it matters, like with remote management in Fleet, you can quickly deploy your new policies or integrations, or you can update hundreds or thousands of agents in one click. So no more logging into each host or doing SSH into your VMs or updating each beats config manually. So now let's drill some deeper into more key benefits of agent ingestion and how it addresses many of the headaches we have seen with the beats. Now, as you can see, like if I talk about some security and privileges, so Elastic Agent uses automatically generated APIs for communication with Elasticsearch. So this is more secure and far simple than manually provisioning credentials for each beats on your every host. And also the agent can run with minimal privileges. So you reduce the attack on your servers. And let's say I will give you insight on performance gain as well. So let's say when your data is split across multiple, like more focused indices, so your queries can be more performant. And you can avoid the mapping conflict scenarios as well, like where you have one giant index and you have everything whether in that particular single index, like everything from logs, metrics, and more. So it gives you flexibility, like you can choose only the integrations you actually need instead of enabling everything. So this reduces the resource consumptions on your host. And this is the question for the audience one more time. Like, what do you think so far is a key advantage of using Elastic Agent over Beats in terms of deployment or management? So let's wait if any one of you can quickly write a key advantage of using Elastic Agent over Beats. Let me see in the chat if I have some response. Okay, I can see a response from Parivesh and Naman that, and yeah, they all are very good points. Like you can manage your agent centrally using Fleet. And definitely, Naman, it will provide you easy management and configurations. So yes, like there are a lot of key benefits of agent based ingestion over beats. Now, let's see how this simpler approach extends to an even more user-friendly experience in Kibana with one-click integrations. So, instead of installing modules via CLI, you have a visual user-friendly interface. So this will shorten your time, from, let's say you need to collect data from X source to seeing dashboards in the Kibana. And because many integrations come with a pre-built dashboard, you can insight almost immediately, like no more building everything from scratch. So there are a lot of examples of integrations, like, if I talk about databases, so you get an integration regarding MySQL, PostgreSQL, and a lot of them. And if I talk specific to containers, then we have Docker, Kubernetes integrations available. We have some cloud platforms easily available like AWS, GCP, and many more. So, like, assume it, like if you have used Beats module, imagine that never having to type another /filebeat module enable command again. You can just all do using a single unified Elastic agent. So, like this is for question for audience again. Like, can you all list what all integrations you have used in your daily use case? Like, which integrations can be helpful for you? Like, whether it's AWS databases or containers. So, which agent you have utilized? Which integrations you have utilized in your daily use case? Uh, Let me quickly go through the chat once more time. So I think there, like in the chat, I can see Windows, MySQL, and definitely there are a lot of integrations which I can see listed in the chat. Okay. So now as the integration approach is simple, so let's see how you can quickly start with a web UI. Uh, so in the past, configuring something like FileBeat to collect your logs or metrics involved editing lengthy YAML files. So you have to specify inputs, paths, and patterns by hand. And let's say if you miss a single space or indentation error, it will break your entire config. And each time, let's say if you want to add a new data source, so you will need to repeat this whole process again. So now with the new way, with new integrations UI in Kibana, collecting data is as simple as toggling a few switches. Like instead of editing YAML, you just select the types of logs or metrics you want to collect. Like let's say in this case, in the particular slide, I'm collecting Nginx logs and third-party REST API logs or any system metrics. And I can just toggle off or toggle on any button, and then I can click on save integrations. So once I click on save integration, all the heavy lifting will happen behind the scene. So I don't need to worry about any manual steps or debugging config files. So this visual UI based approach will drastically reduce time to deployment. Like you can see that rather than spending your hours researching that how to write this lengthy YAML config files, it's more accessible for your team that might not be comfortable in editing all your YAML. So now both your operations and non-operation folks can collaborate on this data policies. So this slide perfectly shows how Elastic Agent and Fleet shifts the experience away from configuring multiple beats in a text file, like a YAML file, to a more centralized and a user-friendly process. So it's all about speeding up your journey, like from data ingestion to insights. So going forward, now you can enable your data collection, like for your new services in minutes, like no more guesswork, no more manual installations. You can just toggle off check boxes and let the platform do the rest. So now the integration approach is simpler, but what about security threats? So let's look at how you can protect host just as easily. So right now we have covered all the things related to data. Like collecting data is very easy, but how it feels, like how it sounds like, while you observe, why not protect? So automated response to collect security threats like malware with one click deploy an Elastic Agent. Like Elastic Agent also supports endpoint security for your malware protection. This means your same agent collecting logs can also protect host in the real time. So if your agent detects malware, it can block it automatically, like you are cutting down the time to detect and respond. So there is a single pane of glass, like from Kibana's security dashboard, you can see alerts, you can take actions, and even isolate your host if you need to. So now let's talk about how we can actually manage this large deployment of Elastic agents using Fleet, especially if you have 1,000 hosts. So there is a fleet UI where you get a quick visibility to fleet status. You can manage your thousand of hosts and one-click updates, no more manual config management. So fleet gives you a real-time overview of all your enrolled agents and how many are online, offline, or how many of your agents need update. Like let's say if you have 10,000 hosts, that's just a handful of clicks to apply new configuration. Like you can skip writing your Ansible or Chef playbooks to distribute config files. Like Fleet handle it all with a centralized policy. Also, Fleet track each agent health, letting you quickly identify your problems. And it's a major saver for your ops team. So Elastic Cloud users get this out of the box. And for on-prem or self-managed folks, it's easy to set up. So let's see how it works out of box on the Elastic Cloud. Like integration server is enabled by default and it is free on Elastic Cloud. So if you are using Elastic Cloud, Fleet server is already there. You don't need to spin up or maintain an extra node. It's a load balanced and horizontally scalable. So everything we have shown so far, like integrations and fleet, it runs smoothly in Elastic Cloud. In fact, most of the thing that we normally build ourselves is already there and it's turned on and it's free. So you can call out on the screenshot. Let's say you will notice this familiar Kibana node sizing. And right underneath here is the integration server. So think it as a managed fleet server layer in the cloud. Like Elastic Cloud spins up an integration server automatically. So no extra cost, no separate VM, no Terraform script. The moment your deployment is live, moment your integration server is also live. So as your fleet grows, you can also scale up it. You can just slide into this size per zone and you can add more zones and Elastic Cloud does the heavy lifting. So no lift and shift, no downtime, agent simply keeps checking in. So for teams that would rather spend time on observability and security use case and not on managing fleet server clusters, this is game changing. You can start small, then scale to hundred or thousands of agents without redesigning the architecture. So beyond that, let's look at some advanced features which are available in 8.17 version of Elasticsearch, like collecting logs, metrics, traces, security data, and universal profiling, all through a single agent. So on this slide, we have listed all the features which are introduced or enhanced around Elastic Agent and Fleet in version 8.17. So you will see some labeled as GA, which means they are generally available and ready for production, and few labeled as beta. Like beta features are early previews that will include and fully available in version 9. So let's see, like if you are excited about some new features which are in beta right now, like new enrollment options or your support for automatic deletion of unenrolled agents in fleets. So keep an eye on the release notes and the Elastic blocks for exact timelines. So in short, you can adopt all these generally available features today in 8.17. Like for this beta features, please feel free to try them out in a testing or a non-critical environment. So now that you have a sense of flow, that how all Elastic Agent, Fleet, how all it fits together. So now let's jump into a short demo to see all these features in an action. Okay. So let me first introduce you regarding the demo scenario. So right now I have an Amazon EC2 instance. Like right now I have Amazon EC2 instance running Windows Server with IIS installed. And I will walk you through to collecting logs from both the EC2 platform and the IIS web server. Then I will demonstrate you with the same agent how you can use it for security as well, like how Elastic Defend will protect your host against threats. So by the end of this demo, you will see how it is easy to onboard logs and metrics for observability, and also using the same host, how like same agent, how you can enable endpoint security for real-time threat detection and blocking, like everything just centrally managed from Fleet and Kibana. So first, let me jump into the integrations UI. Like first, I will enable the AWS integration in the fleet. So let me search for AWS integration here, and let me jump into EC2. So here there is an Amazon EC2 integration. So this integration will help us gather some host level logs, performance metrics, and any OS logs from our EC2 instance. So in this fleet integration UI, I will have gone through the Amazon EC2 integration. Now I will add this Amazon EC2 integration. So I just need to provide some, parameters like access key and secret access key. So for my agent to get authenticated with my AWS servers. So let me quickly grab it and paste it here. So I have my access ID. So I have my access key ID here, and then let me grab secret access key, which will help us to, authenticate my Elastic agent with my EC2 VM. So I have put the secret access key and the access key ID. Now, there are a lot of options available in this integrations. Like you can collect EC2 logs from your S3 buckets. You can collect EC2 logs from CloudWatch. You can collect simply a EC2 metrics. So for now, for this demo, to keep it short, I will go with collecting the EC2 metrics. And as my region is like I have deployed my EC2 instance in US West 1 region, and I don't need to collect logs of all my global region EC2s. So I will collect use my region as US West 1, and I will create it for a new host. Like let's say we'll give it as a name, like agent policy name as a test, and I will save it, and let the magic will happen at the back. Like I just need to install my Elastic agent on my host, and then I can see my data flowing from EC2 instance into my Elasticsearch. So it will give you an option like your integration has been added. Now you can add your Elastic agent to your host. So it's all through Fleet UI. So now here you will see options to, how you can install Elastic Agent on your host. And as I told you, I have my Windows server ready. So let me quickly jump onto the Windows EC2 instance. So this is my Windows EC2 instance. And here you will get all the commands to install. Like you can just copy and you can just paste into your terminal to install your Elastic agent on a single command line interface. And like I already have my Elastic Agent zip installed. So let me just go over this zip uh, and install this. Like this is the command for installation, and this will install my Elastic agent on this particular EC2 host. So here you can see in this command, like it is just passing an URL, which is my fleet URL and the enrollment token to verify. So let me install it. So it will be asking you that, let's say if Elastic agent will be installed at this path and it will run as a service. So do you want to continue? So I will do yes. And now it will take, like almost half a minute to install my Elastic agent on this particular host. And once my Elastic agent is installed, then I will give my agent, like it will give my, like see here, like I got my single green click that my agent has been successfully enrolled. And here also I can see that my Elastic agent has been successfully installed. So how I can verify now that if I'm getting an AWS in EC2 data or not. So if you open this particular integration, so there are a lot of pre-built dashboards available for your EC2 logs, matrices. So for now, I will open any one of the dashboard for EC2 overview. Let me find out how one for EC2. Okay. So there is one dashboard named as Metrics AWS EC2 overview. Like this is a pre-built dashboard, like out of the box dashboard, which is available for you to just to give you an overview of your AWS EC2 metrics. And let me quickly open this. So here you can see this, and let me do it last 15 minutes. Okay. So here I can see, I have seen my EC2 host mentioned here. Like if you see my EC2 instance ID, I can see this instance ID listed here. and I can see the EC2 instance state as well, and it's running, and the EC2 instance state is 100%, like state is running 100%. Also, if I increase some time frame, let me do for all last 7 days. So I can see all of my data, like how much EC I have got as a network in bytes, how much I got network out bytes, like disk IO. So there are a lot of details, and this is just a pre-build, like pre-built dashboard just to use and ready to deploy. So this is how, uh, you know, uh, so you have noticed that we haven't touched any YAML files. We just select what logs or metrics we want, and Fleet handles the rest. So now I can quickly jump onto another integration, which is an IIS. Like I have my IIS server ready to. So let me quickly jump into IIS integration. So again, we will go to the integration UI, and let me quickly jump into the integrations UI. And I will quickly jump over the IIS integration to collect IIS access and error logs. Again, we will do this from a fleet. Like we search for the IIS integration and simply add it to our agent policy that we have created, which is a test policy. So let me add this IIS integration, and it will give you multiple, options that you can collect IIS access and error logs, whether you want to collect IIS application pool, web server, and website metrics. So I will enable all of them for now. And this log, like this will give you all your logs, HTTP request, errors, and performance data from our web servers. Like let's say if you are running multiple websites or microservices on your IIS, so you will get all your data aggregated in one place. And because your IIS logs can be verbose, so it's helpful that your Elastic integration automatically will parse all of your fields, like whether it's client IP, HTTP status, codes, or request URLs. And it will structure all of them so quickly, and you can filter all of them and build visualizations. And also, it offers a lot of pre-built visualizations. We will see it after once we will save it. So I will just want it on an existing host, which is my test. And you can see, I'm not touching any YAML files. I'm not writing any lengthy YAML files. It's just to a single web UI, which is a integration and fleet UI. And now I will do this save and deploy changes, and all the work will happen on back, and my data will start flowing into Elastic. Like I can see my IIS data. So let me quickly jump into the access and error logs. Like here, you can see we have a lot of pre-built dashboards available, which will show you access and error logs for your IIS integration. So let me quickly jump over it. So you can see I have some data coming in. I can see my error logs over time. I can see my response codes over time, and you can filter based on it. Let's say I want to see how much response, like let's say how much count I have got for a particular this response code, like 200. So it will filter out based on that. And this is just pre-build, and all everything managed using a single fleet web UI. You can see a lot of information. Like I have just opened a single, dashboard for this particular demo, but we have a lot of out of box dashboards available. Like you can see your browser breakdown, your operating system breakdown. So I can see my data flowing in just with a single, click, or a single access logs and single IIS integration. So now, you can, now I think let's turn on to the Elastic Defend. Like this is Elastic Defend is for your endpoint security and your EDR feature. So we will see how it will offer you real-time threat detection on your EC2 host. So let me quickly again go to the integration UI in the fleet, and it's all through UI. Like I'm not editing any lengthy YAML files again. So here is a Elastic Defend integration available. So what Elastic Defend will do is it will continuously monitor your host for your processes and file changes. Like let's say if it detects some malicious behavior, then like let's say unapproved executables or some known malware, it will stop it, block it, and alert us about it. So you can see like how using a single host, I'm collecting my logs, matrices, but on this parallelly, I can also I can also do a security use case. Like I'm using multiple use cases at a time with a single Elastic agent, whether it's observability or security. Like I'm collecting data, but at the same time, I'm securing my host as well. So let me give it as a defined, like you just need to provide your integration name and you will get some configuration settings to choose from, whether it's a data collection or next generation antivirus or essential endpoint detection or complete endpoint detection. So for now, I will go with a complete endpoint detection for my host and for this demo. And as usual, I will go with existing agent policy, which is test policy, because on this particular agent policy, I have my agent already enrolled. So let's save and continue, and all the magic will happen at the back. And let's see if my Elastic Defend is going to work. And how I'm going to test it is using one of the file, let's say, let me quickly jump. So for the demo, like have a small test file or a script, that will simulate malicious activity. So this Iker file is a malicious file. And when I try to run it on the EC2 instance, so let's see if my Elastic Security or Elastic Defend will prevent me to install it and will give me a notification. And let's see that how the agent responds in the Kibana security. So I have this file and I will try to open it. This is a malicious file. And let's see. And this is from Windows that this application may cause damage. But I can see that my Elastic Security also triggered an alert, which is, you can see I got an alert when I'm trying to install this malicious file. I got an alert from Elastic Security that Elastic Security prevented this file to install. And it's suggesting me to don't run this file because this is a malicious file. So using a single, Elastic agent, and let's verify it, when I try to run it on EC2 instance. So let's see that how our agent respond in Kibana security alerts tab. So let me open my alerts tab as well. So if I go into the host view in the Kibana, and if I go into the alerts, and if I look for my last 15-minute alerts, okay, right now it didn't populate it. Let me check. Okay, for last 30 minutes. Last minute. Okay, so here you can see that when I try to install some of the alert, like a malicious file and my host, then my alert get populated, and same I can verify it in my Kibana security alerts tab as well. So you can begin this, like as soon as I execute that malicious process, we got an alert in Kibana as well as on my host as well, that Elastic Defend blocks it or or prevents us to install it, like depending on your policy settings and all the logs and all the relevant details. So with this integrated approach, we have just not collecting logs, we are actively protecting the host as well. So this will eliminate your need for a separate endpoint security product on top of your observability stack. So has everything we have seen as far, like AWS, Windows logs, IS logs, and security policies, we all configured from one place in the fleet. We haven't edited any lengthy YAML files, haven't deployed, like we have just installed a single Elastic agent on a host. So that's the key advantage. Like you don't have to do a SSH into each box or push your multiple config files. Like it's just a single UI driven workflow. So if we have 100 of instances, we could apply the same policies. Like you have thousands of EC2 instances or thousands of servers. So you could apply the same policies at scale, like automatically enrolling them into the same or, varied on depending policies, like depending on the role. So I think now we can jump on to the architecture side of, like, we can jump on the underhood, that how Elastic Agent works underhood and how Elastic Agent architecture works. So I can stop sharing, and Sarvag, you can take it from here.
Yeah, for sure, Yash. That was a wonderful demo and a presentation. Let me just quickly share my screen. Perfect. Okay. So yeah, now let's take a minute to, dive a bit deeper into what's actually available for you to use today. Let me first tell you the architecture blocks, then we'll understand what's happening behind it. So firstly, in this diagram, this is the agent-based ingestion architecture. We have the Kibana right here, and we have the fleet server, We have some Elastic agents that will be deployed on your server, and we have the Elastic Search. Now, so as you saw during the demo, Kibana, it is really the main interface where everything comes together. Inside that interface, there are two key apps, as you can see in the diagram as well. You'll find yourself using this the most. So basically, you have the integration app and the fleet app. They both are UI, integration UI and the fleet UI. Let's start with the integrations. This is really the next evolution of what you can call the beat modules. So each integration knows how to collect the data, how to parse it, how to visualize it right away. And it is not just the data collection. They are doing basically all the heavy lifting for you. You get all these pre-built dashboards, as you saw in the demo as well, and all these ingest pipelines, all the parsing logic, and even in some case you get the security data, even the detection rules, all of that bundled in. And all these integration came from what we call the Elastic package registry, as you can see in the diagram over here at the right. That lives outside the Kibana technically, and you don't really have to worry about it. But in the background, it just makes sure that the right version of the package gets pulled every time you deploy one. Now we have the other side as well. We are using the Fleet app too. So this is basically your control tower. You can say that. With Fleet, you can configure and assign the policies. You can enroll these agents. You can monitor their health. You can push, the updates, and without even ever like touching the machine individually. And behind the scene, these policies are pushed through this Fleet server. Which actually acts as a middleman between this Kibana and your deployed agents. So this Fleet app is basically to push all the updates to your agent and to connecting your Elastic agent to your Kibana. Then finally, of course, we have the Elastic agent itself. These are the single binary that lives on each of the endpoints. One installed, one agent, they say. So it can handle everything for you. It collects the log, the metrics, the APM traces, the security data, even everything. Like it can protect your endpoint as well, all in one go, as you saw in the demo too. So instead of running, the metric bit here, file bit there, audit bit somewhere else, we got this one lightweight agent that can do it all. It is clean, it is simple, it is efficient. Now, let's break down this architecture to understand it really well. Let's think of this Elastic agent architecture as the nervous system of your data infrastructure. So at the top, we have this Kibana, the brain. This is where you build the data collection policies, you install integrations, you manage the whole observability and security thing. Then we have the Fleet server, which is the spinal cord. So basically, it takes the policies of Kibana and distribute them to the Elastic agents. It is basically a coordinator, keeping everything in sync. Secondly, we have the Elastic agent. They are your nerves, your actual nerves. They are running on each of your hosts. And basically, it's like a Swiss Army knife of your data collection. It can collect everything. And, one agent can do the job of multiple beats. And finally, we have the Elasticsearch memory bank, as you can see right here in the middle. It's basically the memory bank. This is where all the data is stored, all the data is enriched, all the data is analyzed in the real time. The dashboards in the Kibana light up automatically using the ingest pipelines and pre-built assets. We saw one of the dashboards in the demo as well. So it was just one click away. You see all the dashboards, all the data coming in really quickly. To understand this better, let me explain it with an example. So let's imagine a company like Airbnb. So instead of using 10 different tools to track their payments, track their bookings, their errors, and their performance, they just run one single agent per server. And then Kibana shows a live map of global activity, error rates, fraud detection, all in real time from their pre-built dashboards. That's the power of the unified data collection. So this was the architecture of the agent and how it is working. Now we'll move on to the Fleet server. Now let's start with the Fleet server deployed as a service. So in this model, we have this Fleet server, which is deployed as a service. It is hosted, managed, patched, and scaled entirely by the Elastic Cloud. All we need to do is just deploy this agent and we are good to go. So let me walk you through this diagram architecturally. So we have the Elastic agent right here in the left side. They are on your servers, on your cloud, or virtual machines. But of course, here is one more new block, which is our cloud proxy, or you can say the load balancer. So for now, let's just call it the Elastic Managed Traffic Router. We'll get to this once again. Other than that, we have the Managed Fleet Server, which is our Elastic hosted policy hub, as we know. And we have our Elastic Cluster, which is our data warehouse in the cloud. So when you're using Elastic Cloud ESS, basically as Fleet as a service, so Fleet Server becomes even easier. It is hosted and entirely managed by Elastic. So what we can do is we can understand how it works. So your Elastic agent, whether they are running on your servers, your VMs, or your containers, wherever, they still run like before. But instead of connecting directly to a Fleet server, they go through a cloud proxy. So you can now think of it as a smart traffic router where it figures out which Fleet server instance is closest or which is the most available instance. And just like, like your Google Maps reroutes you around the traffic, the cloud proxy do the same. It will give you the Fleet server that is the most available and that is the closest to you. So the fastest route it is. And once the agent checks in, and gets its, the marching orders from the policy we define. Like, for example, let's say monitor the AWS S3 bucket logs, or, as in the demo, we use the EC2 matrix. So as the agent gets the orders, it starts sending the actual data directly to Elastic now. For in this case, it skips the Fleet server entirely at this point, because the Fleet server isn't moving the data. It is basically the policy brain here. It keeps the agent, up to date and push the config changes, make sure everything is sync. But the actual data goes directly to Elastic. For example, let's say we can imagine the Netflix servers during a holiday search. Suppose there is a holiday search and tens of thousands of Elastic agents are checking in from servers and containers all over the world. So behind the scene, what will happen is this cloud proxy intelligently routes this traffic across multiple Fleet servers, making sure that it stays balanced. Meanwhile, of course, Elasticsearch will do the auto scaling in real time. It can handle petabytes of data of logs and matrices. And the best part here is that you get the observability dashboards and Kemana that lights up before the users even notice a problem. All the dashboards are there. So basically, if you want zero maintenance, you want seamless scalability, you want effortless policy management. So Elastic Cloud delivers that. Now we have another option here, which is our self-managed Fleet server. So this is basically to define your own rules. We just flip the script from the for this one. We have the same architectural box, which is our Elastic agent right here in the left. We have the same Fleet server, the same load balancer, and the same Elastic cluster. But we have seen how this Elastic Cloud makes life easier by managing our Fleet server for you. But not everyone can or should go fully cloud. Maybe you are in a highly regulated sector. Maybe your data is simply not allowed to leave your firewall perimeter, or maybe you are dealing with something critical infrastructure like power plants or your hospitals or defense systems. So that's where the self-managed deployment, the Fleet server, comes in. This architecture puts you in full control. You host the Fleet server yourself on your own VMs, on your own bare metal, and typically something like Red Hat Linux or Ubuntu. You pair that with your own load balancer. You can either use the HA proxy, AWS ALB, or F5 big proxy, anything. And your own Elastic agents are deployed across your own on-prem servers, your edge devices, or even a hybrid environment. And they are connected to that Fleet server through a load balancer. Basically, this means that you can enforce policies like suppose only connect to a Fleet server in Frankfurt if you are in a Europe server. Like that, you can define your own rules. This gives you a strong regional awareness, the data residency and compliance, and secure network segmentations. But of course, this doesn't stop here, because you can run this agent completely in a air-gapped environment as well. where you have no access to the internet. For example, think of a hospital. Let's say they want to monitor all their MRI machines or their patient portals. So they can't risk exposing it to sensitive systems. So what they will use is they will define their own use. They will use their own on-prem devices. They will define their own firewall rules. So in this setup, you own everything. You define your and manage your own TLS certificates. You handle horizontal scaling of your Fleet server. You do that on your own. You configure the firewall rules, the DNS routing, and even the HS setup. You even manually sync the integration packages if you are online. If you ever go online, you'll have to manage and sync your own integration packages. So, as Uncle Ben once told Peter Parker, with great power comes great responsibility. So, if your Fleet server ever goes down, the agent will keep shipping data to Elasticsearch thanks to the local configuration. But they won't be able to fetch, new policies and receive updates and enroll new hosts like that. So it's kind of like running your own private cellular network. It is powerful and secure, but you need to monitor it, you need to patch it, you need to scale it yourself. So if you are the type of organization that says we don't trust anything unless we can touch the box it runs on, this is for you. Now let's move on to the summary. Let's wrap this up. By now we all know that Elastic Agents, simplifies our data collection. Whether you're dealing with logs, metrics, or security events, it is just one agent that delivers it all. You don't need to juggle with multiple beats. And with this centralized policy management via Kibana, you can onboard new data easily with multiple sources in minutes. You can do global changes instantly. And if you are using this Elastic Cloud, Elastic Managed Fleet server for you, you can scale effortlessly and stay up to date, focus on your apps instead of do all the plumbing. And of course, if you are in the self-managed setups, Elastic will give you full control to run the Fleet servers on your own terms. But of course, you'll have to do you'll have to decide the rules. You'll have to do some of the plumbing in this case. But so whether you are Netflix, you are a healthcare provider, Elastic Agent is your nervous system, flexible, scalable, and always in sync with your data. Thank you.
Awesome.
Now,
Thank you.
move
Thank
on.
you so much, guys. We go to the Q&A section now, and Sarvagya and Yash will take the lead on those. Okay, Sarvagya or Yash, this is a question from Naman. Can we automate integrations and agents using IAC tools?
Yes, like I can take this question, and definitely, Naman, you can automate that, like installation of Elastic Agent. As I told, let's say you have thousands of servers, so you don't need to manually run command on each and every server. You can just write an Ansible playbook or using any ISC mechanism. You can definitely automate the installation of it.
The next question is from Ayush. Ayush says, when deploying Elastic Agents on EC2, how resource intensive in terms of CPU utilization and memory are they in real world scenarios? Are there any performance considerations we should keep in mind?
So like, Elastic Agent on EC2 is generally lightweight process for like most your observability and security workloads. But I think there were some recommendations, in case of EC2 instances, like let's say you have at least two CPUs or two vCPUs and let's say 4 GB of RAM per EC2 instance for agents. And, or either you can play with your data collection frequency, like when you try to when you go into integration and try to install some of the integration, you will be getting an option to define your data collection frequency. So definitely you can try to lower that if you are facing issues. So yeah, these are some of the recommendations which you can follow. But yes, I think
Yeah, I would like to add something here because if we talk about the memory usage, the memory consumption of these Elastic Agents are mainly influenced by the number of integrations or the amount of data is being processed. If you have a large amount of data, of course, it will take a little of the memory usage or more of the memory usage. And if you have some little data sets, it will definitely be lighter. And if I talk about those consideration of performance, definitely we have different types of things like resource limit. We have we can define our own agent configurations. We have to fine tune them based on the needs.
Okay, awesome. I think we'll Dhruvi seems to have answered this question from Pratik, so we'll skip that one. But there's another question. As I have more than 10K host deployed Elastic agents, as API, can I retrieve only the 10,000 agents at once? How will you deal with this kind of infrastructure?
So, when I talk about Elastic's Fleet API, it will return only up to 10,000 agents using default pagination, but you can use paginations with, page and per page parameters, and you can iterate over it. And I think other option would be bulk agent upgrade. You can try to automate it basically using a Python script as well. But I think Fleet API also supports bulk upgrades, where you can pass either your agent IDs at once, or you can pass your policy ID, and all the agents that is particular, is enrolled in that particular policy, you can install all of them at once. So definitely you can automate it via script, or you can like Fleet API support bulk upgrade, so you can do all under a one policy, or you can pass all your agent IDs. So this is something which we can do, but definitely like Sarvag, if you need to add anything, you can.
You covered everything right here. We can definitely add it by using the page and per page parameters. That's the best thing.
Okay, and then what's the difference between Fleet server and integration server?
So I think that's a nice question, and usually people get confused between what is difference between fleet and integration. So I will give you a quick answer. Like Fleet server just manages your Elastic agent policies and check-ins, and whereas integration server is your backend service for integrations like APM and universal profiling, and it is available in Elastic Cloud only. Like you don't have, like when you try to create it on an on-prem environment, then definitely you have a Fleet server. You don't have an integration server. Like integration server is available for Elastic Cloud users only. So definitely this is a confusion which usually people get in terms of Fleet server and integration server.
Yeah, the Fleet server is there only to manage, the life cycle of Elastic agents, like including their deployments or any upgrades if they require. But here, the integration server actually collects the data from the various sources and actually do the stuff of define how you want to collect the data. That's the difference between them.
Okay. We have a question here from Nitesh as well. Let's say the log file location varies across different servers. Is there a way to pass environment variables or dynamic values into the Elastic Agent integration to handle that?
Yes, definitely. When you are, let's say, I talk about a custom file integration or a file integration, and your path varies. So definitely you can use some predefined variables, and either it can be on your index, like, like let's say agent.hostname, or you can define your custom variables in your Fleet policy, and then you can use that path variables. And when you are defining the integration, or when you are installing that particular integrations. And we have done that a lot of times, because every time your log file location can vary, and definitely you can pass environment variables.
Awesome. Right. I have a question as well from Pratik. He says, will Elastic Defend causes the performance issue on host if it's a huge application running on the end machine? He observed that some of the users are complaining and CPU utilization more than 40 to 50%.
So yeah, like it's true, Elastic Defend can cause significant CPU overhead, and especially on, like your resource constrained host, or, like servers which are running very heavy applications. So, and why this is the reason, because, like what Elastic Defend do is it does real-time scanning. So it constantly monitors your processes, file system, registries, so, or your spikes on CPU. And definitely it need to do memory scanning for malware protection as well. So definitely you can have some CPU high usages or spikes, but how there is some suggestions or recommendations that how you can mitigate it. When you try to do a Elastic Defend integration, you can tune your security policies, like you can disable components that you don't need, or you can exclude some of the processes if needed. So these are something I think which you can use to, usually avoid this behavior. But definitely, as Elastic Defend integration is a resource intensive because it continuously monitor your host, then definitely that can be the case.
I'm going to Rishabh's question now, just for the sake of time. What if I can't install the agent on application service directly? Due to security reasons, what are my options to collect data?
I think that's a great question. Like, let's say if you don't, if you're having a host where you can't directly install any agent. So I think that can be done via, let's say, there can be many cases. Let's say if you don't install any Elastic agent, then either you can go with remote log shipping, where you can use syslog forwarding. Like you can forward all of your logs into a host where you can install all of your agent, and you can do syslog forwarding from your app server to a secure log collector or a log collector server. And you can use various syslog protocols like UDP, TCP, and basically this is used for your syslog devices as well. Like let's say if I have an internet, I have a browsers, like I have a Wi-Fi routers or any syslog devices, I can't install my agent directly on that servers. So definitely you can route it using syslog into a different server where you can install your Elastic agent, and you can use it to collect your data.
Okay. Our last question today is from Ansh. He who says, with microservices-based architecture, do we need to have multiple agents, and how can we observe that kind of application with Elastic?
So, in a microservice-based architecture, you don't need an Elastic agent for your every microservice. Let's say if but rather you will be needed on a VM base. Let's say if your microservices are deployed on each different VM, then you need it per host. But let's say if your individual microservice is deployed on a single host or a single VM, then definitely one Elastic agent will work for you. But if your microservices are deployed on different VMs or different hosts, then definitely you need to install agent per host. Like it's not agent per microservice, it's agent per host. So it depends on how many hosts you have installed your microservices.
Exactly.
Awesome.
Like with a single Elastic agent, you can definitely collect multiple service, but they should be on a single host, is what it means.
All right. Well, Sarvagya and Yash, thank you so much for your time. You guys were amazing. Thank you for answering all those questions. Here at Hyperflex, we are so fortunate to have expert Elastic engineers like these two that you met today. And we have a team of about 30 certified Elastic engineers. And we are proud of them and their expertise and how they help companies get the most from Elastic. If you want to learn more about us and our services, you can follow us on LinkedIn, reach out to us on LinkedIn, reach out to us via email, or find us on our website. And also keep track of us by following us on LinkedIn, because that's where we will release our recording of today's webinar. Give it about a week's time, and then we will post the recording or the access to the recording there. And then we also always like to invite others to co-host the webinars with us. We have these monthly. So if you are interested in sharing your expertise with us and the audience, please feel free to reach out to us in the aforementioned ways as well. We'd love to learn from you and your experience. Thank you so much for joining us today, and hope to see you next time. Thank you. Bye-bye.